Welcome to the existence and uniqueness theorem. So I'm going to do a slightly different theorem from what's in your book, and then we'll sort of get into the more detailed specific theorem that your book has. So the theorem says that if P of t or P of x and G of x are continuous on the open interval AB and the open interval AB which contains x naught, then the initial value problem y prime plus P of x y equals G of x with initial condition y of x naught is equal to y naught has a unique solution on the interval AB. Just a couple of things to note. Has a unique solution implies two things. So note, this means two things. First up, that a solution can be found or a solution exists. Second, the solution is unique. So meaning if y1 and y2, actually let's not use 1 and y1. Let's do if ya and yb are both solutions, then ya equals yb on the interval AB. So this is why it's called the existence and uniqueness theorem, because that theorem gives us both of these. So for the existence, we have already seen that y equals u times y1, where y1 is equal to e to the negative integral of p of x dx, and u is equal to the integral of g of x over y1 dx is a solution, right? Or is the general solution. Right? So we essentially have then that y is equal to, I'm gonna actually put this earlier. Right, so y therefore was equal to y1 times the integral of g of x over y1 dx plus c times y1 is the general solution. Okay. And then to make our lives easier, we can go ahead and for the particular solution, do a definite integral. So for the particular solution, we can take y to be y1 times the definite integral from x naught, our initial condition, to x of g of t over y1 of t dt plus c times y1. And if we plug in x naught, that definite integral will go to 0. And so what we get then is, if we plug in x naught, update my screen. Plugging in x naught, we have y of x naught is our y naught is y1 of x naught times the integral from x naught to x naught of g of t over y1 of t dt plus c times y1 of x naught. This part here just goes to 0. Integral from x naught to x naught will always be 0. And so we wind up getting then that c is equal to y naught over y1 of x naught. And so we have particular solution. So we have the particular solution. Y equals y1 times the integral of g of x, oops, sorry, g of t. Let's put back in our x naught to x. So y1 times the definite integral from x naught to x of g of t over y1 of t dt plus y naught over y1 of x naught times y1. So this is showing that we have a solution that exists. This is the formula for it. We can directly find that solution. For uniqueness, I'm not going to run through the proof of this. So for uniqueness, see the textbook for the proof. So technically your textbook, the theorem was specifically that the particular solution is what I have written just here. So I've essentially given a slightly more general theorem that didn't give the particulars, and then delve down to the particulars that are in the textbook. So this is the existence and uniqueness theorem. As long as you have that open interval on which P of t and G of t are both continuous, we do then have that we have this unique solution to our IVPs. If it's not an IVP, we'll just have a general solution.